CGP, Maths Foundation, Set 1, Paper 3. It is a calculator paper. (14:30) train is this one from Douglas. Start at 14:30. Arrive at Port St Mary at 15:26. Do we cross over an hour in the middle? Yes. We get to 1500 hours. That's a 0. How many minutes between here and here? How many minutes between here and here? Paul arrives at Castletown station at 14:50, so this is when he arrives. How many minutes would he have to wait before he can catch the train? The next train, if he arrives at 14:50, is here at Castletown, so 15:07. Is there an hour? Does it go to o'clock in between? Yes, it does. And we do exactly the same as above. How many minutes? If you're not sure of your negative numbers, draw a number line and work it through. Is 5 greater than 3? Yes. Is 5 greater than, so 5 is greater than 3. This is greater than this? Yes. Is 5 greater than negative 3? Yes. Is negative 5 less than 3? Negative 5 is less than 3. Is negative 5 greater than negative 3? No. So write exactly what's written above. Don't just ring it, you actually have to write it. Write down, it says. Write down the equality that is false. Write it down. So a face is, each of these is a face. This is a face, this is a face. This is a face, this is a face. When you connect them together, this space in the middle is no longer a face. So we have in each pyramid 1, 2, 3, 4 faces on the top, and we have 4 faces down here, because we've got a pyramid here and a pyramid here, but we do not count the faces in the middle because they're stuck together, and an octahedron is all of the outside shape, not the 2 in the middle. Vertices. So faces are here, vertices are these 1, 2, 3, 4, 5, 6. And the edges are the lengths. Let's do it in a different colour slightly. Are all of these. 4 along the top, 4 here, and 4 more here, which gives us 12. Oops, sorry. So we're looking where the graph is steepest. Sorry, graph is the least steep here. So it's what was it in April? Now we need to look carefully at the graph to make sure we know what's happening here. In April it's here, in October it's here. There are only 5 squares for each one, so each square is 0.2. So this is 0.8 and this is 2.4. Now it is a calculator paper. Use your calculator. 0.16. Sorry, 1.6. 1.6 meters. It says 1.6 on there. Right, important calculator. All right, I'm going to do this slowly and so that you can see as many buttons as possible. Let's move this one up. Right, starts with a bracket. Try and replicate it with a Casio calculator. It's easier because you've got a fraction button. Replicate it as closely as you can. Shift and the square root button gives us a cube root. Don't just ignore that little 3. It's really important. Now, to do this big bracket here, I needed to click the right arrow twice, and then I have a big arrow. I then click on the squared button, and that puts the little squared sign here. That is it. And you write down that number. Three decimal places. First, second, third decimal place. This is where we draw our line. We're rounding up with the 8. Two shapes are congruent. Congruent means the same. They can be a mirror image, and these two are indeed that. They're a mirror image of each other. Which one of the shapes could not be used as a net of a cube? It is C, because these squares are on the same side. If you folded it up, there'd be nothing to close the lid on this side, but there would be 2 on this side. Commutativity means that we can move these around in any order. And these multiplication signs are invisible. How many chances are there of her picking a letter S? There are 1. How many are there in total? There are 8. 1, 2, 3, 4, 5, 6, 7, 8. We need it as a fraction. In its simplest form, we can't simplify that anymore. Probability she picks a card with a V, and we add that to the probability she picks it with an H. There's 1 V and there's 1 H. We need it as a decimal, so we could put that into our calculator. There's 1/4, but we need a decimal, which is 0.25. And finally, we need a percentage. Work out the probability she picks a card that does not have the letter A on it. These are all A's, so we count the ones that are not. 1, 2, 3, 4, 5. not A. There are 5 out of 8 that are not A. We need it as a percentage. .625 is the decimal. We multiply that by 100 to get 62.5%. This means it isn't -2, it's greater than, n is greater than or but not equal to, so we cannot have as -2, it's not in our set of values, so we can't have -2, so the first integer is -1, 0, and then we can have 1 because n can be equal to 1. We're dealing with integers, that's whole numbers. This is the amount to get the full 3 marks. So I'm going to take 100% and take away 42%, which gives me 58% males. We take 150 members, multiply by 58 divided by 100 because we need to make it into a decimal. 150 multiplied by 58 divided by 100, 87. So you can choose either ham or tuna, either fries or salad, and either cola, orange juice or milk. So we can start with ham, and we can have that with fries, and then we can have cola. We can also have ham and fries and orange, and we can have ham and fries and milk. We can have ham and not fries, but this time salad and cola, ham and salad and orange, ham and salad and milk. We can have tuna and fries and cola. Yep, COM, 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 H, H, T, T, F, S, F, S. Make sure you've got all the combinations there. You can use this to simplify. You've got 28 and you've got 4. Oh, that's not 4, that's 4. It gives you just a 7, so the answer is 7A. Okay, so the centre is at 3, 2, so the centre is just there. Coordinates for the other point where the circle crosses the y-axis. Where's the cross the y-axis? Well, it crosses, lighter cut, it crosses just here. So it crosses here and it crosses here. So what are the coordinates of that point just there? Well, x equals 0, just like it does up here. Remember, you need the brackets for coordinate. 0, and this is crossing at -2. This line here crosses the circle at a tangent. Well, it touches the circle at a tangent. Equation of the line A. A crosses the y-axis at 7. So y equals 7 here, but y equals 7 all the way along here. Area of a circle. What's the formula? So to work out the area of the circle, I need to find out what r is. What's my r? R is my radius. What's my radius? Well, it's the distance from the midpoint to the edge. So here it's going up to 7, and here it's going down to 2. So I can take 7, subtract 2 equals 5 units, and this is my radius. So I substitute that in. R squared, 5 squared is 25 pi, and we put that into the calculator. And it says it wants it in 2 decimal places, starting at decimal point 1, 2. So what are we doing here? Well, we're hiring a car for 4 days. So what's the cost of just the car hire? Four days and the daily hire charge. And now we need to find out now we found out litres, we need to find out the cost of that petrol. So we now have two amounts. We have the cost of the hire car and we've got the cost of the petrol. Both of them are in Swiss francs. So we add those two together. Exchange rate. So start by getting to 1 Swiss franc. What do? Well, we divide that by 1.42. That's the exchange rate. Whatever we do to the francs, we do to the pounds. At 50 divided by 71. At the moment, I'm just going to leave it like that. You could make it as a decimal if you prefer. I'm then going from 1 Swiss franc to 454.30, our cost up here, which is an exact amount. Brings us to 4. So we take the decimal or the fraction we had before and we multiply that by 454.30. All I've done there is press the equal button. That automatically puts the answer in here. Answer is whatever an answer we had before. And this answer here, I'm just going to write it out bigger. What are we doing to the nearest pound? Okay, so this is £319, but is that the nearest pound? Let's put my dotted line here. 3, 1, oh, 9 actually rounds the 9 up, but 9 can only go to 10. In this case, it means that we have to then round to here. Don't often get those. 9 rounds up. We can't take this up, so we take it down to 0, but then we have to round the next number up. If you think about it, we've got 319.9. Where can it go up to the next? This is £319. What's the next pound it can go to? Well, actually, that's 320. The best way that I see this one is actually to draw more of a table. It's a bit cramped and it goes over the words, but I think it helps. Well, it definitely helps me work out what's going on. We know there are 214 pupils in total, and we know that 15 of the boys went home for their lunch. That go home are boys. 15 of the pupils who go home are boys. And then I'm going to add across. What's this figure here? 214 subtract 64 subtract 126. This subtract this subtract this gets us to 24. And then I'm just going to check by adding those two numbers together to make sure I get this. Indeed I do. So I now have all of the numbers that I need to fill into this table, so at this frequency tree below. How many boys are there in total? Well, there are 1, 1, 2 from here. Girls, there are 102, 102. Packed lunches, boys, 33, 64 and 15. Packed lunches with girls, 31, 62 and 9. Now what's just occurred to me is you could have, rather than working on a two-way table, you could have actually put the numbers in here. You started with a 15 here, you knew that there was a 33 here, and you knew that there was a 31 here and a 62 here. Actually, you knew the 64 here, so you could have just added those three together to get the 112. You could have added those three together. Yeah, you'd have had to work. I like a two-way table. Lots of people do. It's your choice. You either work directly from the tree or you create yourself a table. Your choice. Reciprocal. Reciprocal means we take a number, in this case a decimal, and we change the numerator and denominator. Some people call it flipping. Now, if we've got a number, it's got an invisible 1, it's a fraction over an invisible 1, so the reciprocal, and we put that into our calculator. I'm going to use the fraction button. And then what we're going to do is three significant figures. 1, 2, 3. Five rounds up to 6. That's the decimal point, so we have to make sure there's a 0 to make sure we maintain the place value. And that's it. litres per minute. Litres per minute can be written like this, and it says the flow rate is in litres per minute. So we write the number of litres, which in both cases is 400, 50 minutes to fill using the kitchen tap. So 8 litres per minute, 16 litres per minute. If you've got both of them going at the same time, the rate is 8 plus 16. It does say they don't affect each other's flow rate. It's not like when you're in a shower and somebody flushes the toilet and the rate changes and it gets really hot or really cold. In this house it doesn't have that problem, apparently. So what we now need to do is we need to rearrange this equation. The rate equals the number of litres over the number of minutes. I'm just going to use these letters. If I multiply both sides by m, then this equation holds. But what we need is the answer in the time. This could be time, m could be time, minutes and seconds. So we need time on its own, the minutes on its own, and this is litres and this is rate. So the minutes equals litre divided by rate. How many litres? So the rate is 24. How many litres in total? Well, the whole paddling pool takes 400 litres, so we work that out. So that's a recurring number, 6666667. So how many whole minutes? Well, there are 16 whole minutes, and then we take the bit that's left over and we multiply that by 60, because there are 60 seconds in a minute. So we take away 16 from this, we then multiply it by 60, which gives us 40. Don't you just love it when a question ends with a whole number, an integer? So what's the pattern? We're adding 3, adding 5, adding 7. So this time we're adding 9, adding 11, adding 13. We add, so 20 plus 9 plus 11 plus 13 . It's that simple. 2 marks towards the end of the paper. And this one, if you know similarity, is also quite quick. We have a small triangle and we have a large triangle. Draw sketches of what we've got. What do we know? From A to D is actually 5 centimetres. Five is big, 2 is small, small triangle, big triangle. So to get from 2 to 5, you multiply by 2.5. To get from 4.3 to this line DE, you take your 4.3 and you multiply by 2.5. We have a calculator. Use it. And the centimetres is there already. 3 points at the end of the paper. Can't be bad. 2 tracks and get a third 3 means that for 3 tracks, for the price of 2 tracks, which is 198 pence. I'm just going to leave it as pence. I don't need 3 tracks, I need 18 tracks. Sorry, 18 tracks. So what do I do to get from 3 to 18? Well, I multiply by 6. And I do that same here. 198 multiplied by 6 gives us 1188. So 1188 is the cost of 18 tracks from here. Smart sounds. 30% off, which means you're left with 70%. Sorry, 30 equals 70%, getting ahead of myself. So what's 70% of 90 pence? Sorry, 63 pence per track. 18 tracks at 63 pence. So here's 134, here is 118. You can see that Smarter Sounds is more expensive. Sorry, it's cheaper. Yes, it is. Sorry. Smarter Sounds is 1134 subtract 1188 equals 54 pence. Smarter Sounds is 54 pence cheaper. Question 24. This is lots of tricky things that actually stumped me when I first looked at this. So, equation of a line, where this is the gradient and this is the y-intercept. Except we don't have a y-axis and an x-axis. Instead of an x-axis we have a d. And instead of a oh, that's confusing. Monthly charge here is actually the c-axis, which means we have to call this something else. So to make it, we're going to call it, I'm just going to put it in brackets to show it's the y-intercept. Okay, so y equals mx plus c is the equation of a straight line. M is the gradient, c is the y-intercept. We have to replace the x with a d. We have to replace the y with a c, and so what I've done is, because it's a different c to the y-intercept, I've just called it something else. We can look at what the y-intercept is straight away. Where does this line cross the y-axis? Well, it crosses it at 10. So already we know that this, is the equation, and we need to find out what m is. So that's what we've got to do next. M equals the change in y divided by the change in x, or in this case here it's the change in c, because this is the y-axis, change in d, which is the data across here. We have an intersect at the grid here, we have an intersect here, so we can use those two figures to draw change in y and change in x, or change in c and change in d. I'm always going to think about it as y and x. So what's the change in y? Well, it's 4 squares, and that is indeed, there are 5 squares in between the 10 and the 5, so each one is 4. So on this triangle here, we are looking at 4 here. Across here, we've got 20. It says here 0 to 20, it is 20. So my change in y is my 4, and my change in x is my 20. So the m is 4 divided by 20. Put that into your calculator. Gives us 1.5, well, 1/5. And actually I prefer it as 1/5. You can have it as 0.2, but I'm going to leave it as 1/5. And then I'm going to substitute that into here. Lots of trickiness in that one. So we substitute -2 into this here. Y equals -2 to the power of 3 plus 2. You see, with a negative number, I've put it in brackets. Really important if you're putting this into your calculator, which I hope you are doing, to put the brackets around. So what's y when x equals -2? So we put it in brackets. -2 to the power of 3 equals -8. You could just put the positive 2 on there. So -8 add 2 equals -6. And so this here is -6. And just to make sure this is accurate, I've actually drawn and plotted all of these points. This is the x when x equals 0, y equals 2. Each square is 1. So I've plotted these points with a pencil and a cross. You need to make it with a cross, and then you need to join them together with a smooth curve, starting from the first point, finishing at the last point. I've actually just gone over that. It wouldn't be marked down, but you want to try and finish it at the last cross. It must go through all crosses. If it doesn't, then what you might want to do is rub it out and start again. Question 26. Now, what we're looking at are two cones. Now, this may not look like two cones, but what it is a large cone with the small cone taken away. So what we're going to do is work out the surface area of the large cone and the surface area of the small cone. So, there's my large cone. Oh, I just wanted to point out, these, because it is a cone and they're two cones that are from the same cone, they are similar cones. And one thing that we can look at, if we chopped this in half, we could look at the radius and put a line down to here. This triangle here is this triangle here. Might be tricky to see it. Might be easier if I put this on here. This is 16 centimetres. This length here is 26 centimetres. And the small triangle is half of both of these amounts. So you have half here, and this small triangle is here, so I'm going to draw that small triangle out. It's half here and half here. So this is a cross section of the small cone. This is the large cone. So that's what we're looking at when we deal with here. The radius of the big cone, radius of the big cone is 16. So the surface now we're given a formula. That's the formula we need to use. Slopey length is 26. Put that into the calculator. 416. It's asked us to keep it in terms of pi, so I'm not going to do anything with that pi. I'm just going to leave it as the number it is, just there. We then look at the small cone. Well, what's the radius of the small cone? Well, the radius of the small cone is 8, and the sloping length is 13 because it's half the original. We know it's half because of this diagram here. It's cut horizontally halfway down its height. So we've got 13 and 8, so the surface area pi RL, pi multiplied by 8 multiplied by 13 equals 104. Remember that pi. So the lampshade itself, I'm going to write it down here, is the big surface area cone, subtract by the small cone, which is, big cone is 416 pi, the small cone is 104 pi, and that is, I mean, you could put the pi in, but actually it's 416 subtract 104, 312 pi. That's what it's looking for, and that's your 80 points.